FlexVPN with dynamic virtual tunnel interfaces. Let's begin. Is FlexVPN really flexible? The answer is yes, it is. For example, if we wanted to take the tunnel interface that we'd created in the previous video, which was tunnel interface 3, and get rid of it, instead of replace it with a virtual template, we could apply the tunnel relevant configuration to this virtual template, and then when we had connection requests for IKE version 2 tunnels, it could create or clone that template and create a virtual access interface. Now, if you're saying, hey Keith, that sounds very familiar, didn't we do that like with dynamic virtual tunnel interfaces? And the answer is, yes, we did. And we can use that same functionality. We're leveraging that technology, if you will, of the dynamic virtual tunnel interfaces as part of the FlexVPN umbrella. Now, the reality is sometimes that we just have to accept things as they change. For example, if we really loved a certain version of Windows and 10 years later that version is no longer available or supported, we have to move forward. And a lot of people feel that way about IKE version 2 as well. And probably it's because so many people are comfortable with IKE version 1 and phase 1 and phase 2. But it's just a matter of time until IKE version 2 becomes the dominant flavor of IPsec that we're using. And some of the benefits of IKE version 2, there's dead peer detection, better integrated with it than IKE version 1, although they both supported it. NAT traversal, where if we're going through a NAT device, it can sense that and pad a UDP header using port 4500, where that NAT device, somewhere between the two peers, possibly isn't prepared to handle port address translation with ESP protocol 50 because it's neither TCP or UDP, and as a result, it can tuck in a little UDP header of 4500, and then the PAT device has no problem with that packet and forwarding it correctly. And if both sides negotiate and set up that UDP shim, if you will, at the front end, it doesn't compromise the security of our IPsec. It's just adding a teeny little bit of a header to the IPsec packets that are going back and forth. Another benefit of IKE version 2, it is better at not wasting a lot of energy until it's sure it can identify who the peer is. See, with IKE version 1, a lot of people could spoof it and try to negotiate an IKE phase 1 policy, and even though they couldn't successfully negotiate it because they didn't have the correct authentication, they could chew up a lot of resources. And that's why with IKE version 1, we use techniques like call admission control to help rate limit the number of IKE negotiations that can be going on at a single time, and or the maximum number of IKE phase 1 tunnels. And it's sort of like IKE version 2 having a surveillance camera at the front door. And it's not going to open the door all the way and have a big conversation with this person until looking through the surveillance camera, it knows who that identity is. There's also support for extensible authentication protocol built into IKE version 2. It uses sequencing numbers and acknowledgments to help maintain the health and welfare of the tunnels. And if we want to, with IKE version 2, we can have a single crypto engine handling our IP version 4 and IP version 6, or we can handle them independently. The choice is ours with IKE version 2. Now, what you and I get to do right now is we're going to go back to R5, which currently has tunnel 3, and we are going to remove tunnel 3 off of the configuration, which R6 is not going to be happy about because we currently have an IKE version 2 tunnel and an IPsec tunnel going on between R5 and R6. But we're going to tear down that tunnel 3 because we're going to create a virtual template. We'll apply the configuration that used to be associated with tunnel 3 to the virtual template, and then still using IKE version 2, we'll have R5 and R6 reestablish their connectivity. But this time, as R6 and R5 talk back and forth, we're still going to be using tunnel 3 on R6, but on R5, the virtual template will spin off a virtual access interface, and the IKE version 2 and the IPsec tunnels will be between that virtual access interface and tunnel 3, between R5 and R6. In our last video, we left R5 and R6 configured with IKE version 2 and a site-to-site tunnel between them. Let's just take a moment and verify that that's still working. Let's do a show crypto IKE v2 SA, and it looks like the IKE version 2 tunnel is still up. For a big picture view, let's do the command show crypto engine connections active, and that will show us the IKE version 2 tunnel as well as its children, which is the IPsec security associations. That all looks good. Let's do a quick ping over to 10.6.0.6 just to validate we have full connectivity between both remote subnets. And that works. That implies routing's working, IPsec's working. And let's take a look at our running configurations, focusing on just the cryptography section. So we'll do a show run pipe section crypto. So here's our IKE version 2 profile. Fantastic. And here we have our key ring with a single entry, which is the entry for our good buddy R6, who's over at 46006. And we have an IPsec profile called default, and this profile is calling upon the IKE version 2 profile called our profile. And everything else that's not showing up here are part of the defaults, including the transform sets that's being used by the IPsec profile. So for fun, let's do a show IP route and take a look at the OSPF learned routes here on R5. And sure enough, here's the 10.6.0 network that R6 has advertised over to us via OSPF. And it's reachable over our local Tunnel 3 interface. Now our challenge is now to take R5 and remove the Tunnel 3 interface that it currently has, and we'll replace it with a virtual template, which can then create virtual access interfaces for the IPsec connections. So this first part, R5 is not going to like, but we have to do it anyway. We're going to do a no interface Tunnel 3, and that's going to bring the OSPF neighborship, the IPsec, and everything else that was going on between R5 and R6 is no longer in place. The rest of the config looks very much like it did with dynamic virtual tunnel interfaces. We'll create a virtual template. Let's create virtual template 1 type tunnel. Now on this template interface, we'll simply replace those same commands. For example, the IP unnumbered, linking it to loopback0, the tunnel source gig 0/0. We'll say the tunnel mode is IPsec for IP version 4. Again, the same commands we used to have on the tunnel interface. Although not required, let's go ahead and be consistent. Let's work with our MTU of 1400 and the maximum segment size adjustment down to 1360. We'll add this interface specifically as part of OSPF Area 0. So when this template is used and we create a virtual access interface, that cloned virtual access interface will also belong to Area 0. Then of course we need to put the IPsec profile on this virtual template with the syntax tunnel protection IPsec profile and the name of our IPsec profile. Now because we're using this new virtual template, we need to make one additional change, and that is to go and modify the IKE v2 profile and simply associate that with virtual template 1, the virtual template we just created. R5 can say, okay, great, I got a connection coming in. It can identify the peer and then associate that new connection with a new virtual access interface. And that's what we're seeing happen right here. So we have this brand new virtual access interface number 1. It came up, and our OSPF neighborship has come up as well. So if you use the command show crypto IKE v2 SA, it'll show us the details of that new IKE version 2 SA. And if we do a show IP route for OSPF learned routes, we should have that one route to 10.6.0 that we've learned. And we should have full connectivity. So if we do a ping up to 10.6.0.6 and we source it from our 10.5 subnet, and there we have it. We have full connectivity from site to site. And this time on the headquarters router on R5, we're using the virtual template as part of our FlexVPN configuration to implement our site-to-site tunnel. Now the big benefit of using the template up on R5 is that if we have hundreds of more branches that show up, if we're using pre-shared keys for all of these associations, we're going to have to update our IKE v2 keyring. We're also going to update our IKE v2 profiles to set up identities for all of these new remotes. However, what we don't have to do on this hub router is we don't have to go in and create a separate tunnel interface to support each of these branches that are coming in. And it's very likely if we had a large-scale environment like this, instead of using pre-shared keys, we'd use digital certs, all of them being assigned by a certificate authority that the routers currently trust. And by using digital certificates, we wouldn't have to create a huge key ring for all the spokes, and we wouldn't have to create a whole bunch of extensive profiles, because we could say we're doing our identification based on contents from the digital certificates, as well as using the digital certificates for authentication. And that would allow for a very scalable solution using digital certificates, and wouldn't require that much change on the hub every time we add a new branch in. Your homework assignment, of course, is to practice. And to assist with that, I've included all the commands we've used in this video to convert R5 from using a static tunnel interface and converting it to use dynamic virtual tunnel interfaces using the concept of the template. So please leverage these files that are in the Nugget Lab files associated with this course as part of your studies. So I've had a great time. I'm so glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.